welcome back to the PACE Academy. So in the previous class we discussed allotropic forms of carbon, right? So in today's class we will discuss group 14 elements, in that chemical properties of carbon. Okay, so in which type of reactions carbon participates and the compounds formed by this. Okay, so in that first one, action of oxygen. So carbon reacts with oxygen and forms two types of oxides. Can you say what are those two types of oxides of carbon? Carbon forms two types of oxides. Those are carbon monoxide and carbon dioxide. So here if we take the carbon and if we heat that carbon in the limited amount of oxygen, it gives carbon monoxide. Okay, so if the carbon is burned in presence of limited amount of oxygen, limited supply of oxygen, carbon gives carbon monoxide. Mono means one. So carbon combines with one oxygen and forms carbon monoxide. Next, carbon combines with oxygen. In the excess amount of carbon, it gives carbon dioxide. Okay, so if we supply limited amount of oxygen, carbon gives carbon monoxide. In the presence of excess amount of oxygen, carbon gives carbon dioxide. Okay, carbon reacts with excess amount of oxygen and gives carbon dioxide, and with the limited supply of oxygen, carbon gives carbon monoxide. So what are the two types of oxides of carbon? Two. What are those? Carbon monoxide, carbon dioxide. Next, action of water at room temperature. Actually carbon does not react with water at room temperature. Okay, so carbon does not react with water. There is no reaction between carbon and water. Next, action of halogens. Which group elements are called halogens? 7th A group elements are called halogens. What are those? Fluorine, chlorine, bromine, iodine. So here carbon combines with all these halogens and forms carbon halides. Okay, so what are those? Tetrahalides. Carbon tetrahalides. If you take fluorine, carbon tetrafluoride. If you take chlorine, carbon tetrachloride. If you take in the place of X, F. So what it gives? Carbon tetrafluoride. If you take chlorine, then it gives carbon tetrachloride. If you take bromine, it gives carbon tetrabromide. And if you take iodine, it gives carbon tetraiodide. And it can also form dihalides like carbon difluoride, carbon dichloride. Okay, so here what are the examples for this? Carbon tetrafluoride, carbon tetrachloride, carbon tetrabromide, carbon tetraiodide. Along with these, it can also form carbon difluoride, carbon dichloride and CHCl3. What is this CHCl3? This is chloroform. What is this compound? It is chloroform. Okay, the chloroform formula is CHCl3. And what is the name of this compound? Dichloromethylene. CH2Cl2, dichloromethylene, and that is chloroform. And so here carbon tetrachloride. Carbon tetrachloride is called pyrene. Carbon tetrachloride is called pyrene. It is the trade name of this compound. And it is used as fire extinguisher. Okay, carbon tetrachloride is used as fire extinguisher. Next, what about CF2Cl2? Difluoro-dichloromethane or dichloro-difluoromethane. This compound is also called freon. This is also called freon. And where we are using that? In refrigerator. Okay, it is used as refrigerator in air coolers as well as refrigerators. Okay, and it is very poisonous gas, so it's slowly depleting the ozone layer. So that's why day by day we are decreasing the usage of this compound. What is that compound? Freon. Okay, next, formation of carbides. So here carbon reacts with metals and forms metal carbides. Okay, so what is that metal here? Calcium. Carbon reacts with, here it is carbon reacts with metal like calcium, forms calcium carbide. Okay, so here it gives calcium carbide. What is the formula of calcium carbide? CaC2. Okay, and can you guess the structure? Here it is, the structure of calcium carbide, CaC2. It is having cyclic structure. Two carbons are attached with 3 bonds, and these 2 carbons are attached with the calcium by forming covalent bonds. Okay, now this calcium carbide on hydrolysis gives, means on reacting with water, it gives calcium hydroxide and acetylene. Okay, so calcium carbide with 2 moles of water molecules gives calcium hydroxide, CaOH taken twice, 2 times. So 2 OH groups combines with calcium and form CaOH taken twice, and this hydrogen attaches this carbon and this hydrogen attaches to the next carbon. So here bond breaks here. Okay, so 2 bonds will break and this OH attaches this calcium and this OH attaches to this from this side. So calcium hydroxide. Next, this hydrogen comes in combined with this carbon, and this hydrogen combines with second carbon and forms acetylene. Okay, CH triple bond CH, and what is the another one? CaOH taken twice. Okay, so this is the calcium hydroxide and this is acetylene. So on hydrolysis, calcium carbide gives acetylene. What is the name of this compound? Acetylene, are also called ethine. It gives calcium hydroxide. So calcium on heating with carbon gives calcium carbide. This calcium carbide on hydrolysis gives calcium hydroxide and acetylene. Next, so those are the properties of carbon. So what are the important properties of carbon? Carbon burns in presence of oxygen and gives 2 types of oxides. In the limited supply of oxygen, it gives carbon monoxide. When it completely burns with the excess of oxygen, it gives carbon dioxide. Okay. Next, it does not react with water, and this carbon on combining with calcium are like metals, they give calcium carbides. So these carbides on hydrolysis gives acetylene and hydroxides. Okay, next here we will read the uses of carbon, where we are using this carbon. Can you guess and say where we are using this? So already we learnt crystalline forms of carbon. What are those? Diamond, graphite, fullerenes, right? So here if we look at the diamond, where we are using this diamond? Diamond is used in jewelries, and it is also used, it is very hardest material, that's why it is also used to cut another hard material, and it also used to sharp the objects, right? So it is a precious stone and it is used in jewelry. So 1 carat is equals to how much? 200 milligrams. So the purity of diamond is measured in carats. Okay, purity of diamond is measured in carats. 1 carat equals to 200 milligrams. Next, graphite. Where we are using this graphite? Already we know that graphite is having layered structure. That's why it is used as a lubricant, and it is also used as pencil lead, right? Next, it is a good conductor of electricity. That's why it is also used as electrode in batteries, right? It is also used as batteries in it is also used as electrodes in batteries and also in industrial electrolysis process. So here, if you want to see this graphite, take a battery or cell, and if we break that, we will get black color powder, right? So that black color powder or the electrode form is actually graphite, okay, that rod. And in electrolysis also we are using graphite electrodes. Why? Because they are good conductors of electricity because of the containing one free electron. Next, it is also used to prepare crucibles in laboratory as they are inert towards acids and bases. So they are not reacting with acids and bases, they are inert towards these compounds, so that's why this graphite is also used to prepare crucibles. Okay, so this is also used to crucibles because they are inert towards acid as well as bases. Next, charcoal. Charcoal is the amorphous form of carbon, right? So where we are using this charcoal, activated charcoal is used as a good adsorbent for absorbing poisonous gases. So here the poisonous gases are absorbed on the surface of this charcoal. So that's why it is used as a adsorbent for this adsorbed poisonous gases and removing coloring impurities from water. Okay, and it is also used to remove coloring impurities. See here, this is the activated charcoal. So this activated charcoal is used as adsorbent. Okay, this one is activated charcoal. So if we send contaminated water through this charcoal, charcoal absorbs the colored impurities and the water will come out. Okay. Next, carbon black. Where we are using this carbon black? It is used in the manufacture of black ink as well as colored pigments. So black color pigments, it is used to prepare or manufacture black ink. Coke is used as a fuel and acts as reducing agent in metallurgy. Generally, in refining process, we are using big furnaces like blast furnace, reverberatory furnace, right? So in that furnaces, we are using this coke as a fuel. Okay, so when we burn this fuel, it releases high amount of heat energy. So for that, we are using this coke. Okay, so coke is used as a fuel and acts as reducing agent in metallurgy. For example, if we want to convert lead oxide into lead, what we are doing? We are reacting this lead oxide with coke. So now this coke acts as a reducing agent and it takes oxygen from this and it gives lead and carbon monoxide. So here carbon acting as reducing agent, by oxidizing itself it reduces lead oxide. So to convert metal oxides into metal, we are using this coke as a reducing agent. So where we are using this as a reducing agent? In metallurgy.